everyone. Welcome to my second lesson for slopes, and I'm going to tell you right now, I'm replacing the notes that I have from the other set of lessons with this one. I didn't really like the other one. This one kind of went into more things that I actually do think are more useful, but there's a lot to unpack here, so this is most likely going to be a two-part video. I'm just saying that right now. A lot going on in this video, I'm not lying. So let's get into it. So in class, you guys have already been working now on some linear equation stuff, a little bit. Actually, you're going to. So what we're doing now is going to really help you for what we're doing in class, honestly. We're going way beyond what Math 6 has. So anyway, writing linear equations. So we're going to be focusing on writing and graphing, okay? The graphing is not too much, but the writing is quite a bit. And when you're in this unit itself, there's going to be a lot of writing, okay? With linear equations. And we're going to be doing it in sloped intercept form. We're going to talk about what that means. So identify the initial value, the Y-intercept. So we've been doing start value in Math 6, but that's actually the Y-intercepts. And I'll talk about what that means on a graph, okay? Use the slope. The slope has been your rate of change. Another word for rate of change is slope when you're doing it in terms of a graph, okay? So use the slope and y-intercept to write a linear function in the form of y equals mx plus b. You're more than welcome to write it as y equals b plus mx. Just gauge your teacher, honestly, because this is standard form, it's going to be written like that. But for graphing purposes, I understand why Math 6 did it this way. So it really doesn't matter. At some point, you'll get used to it from what your teachers are going to expect. And then as someone that's taught the Algebra 1 in the past, this is the expectations that we had for our student, understandably, because standard form, the variables come first and the constants are at the end, and b is your constant. So that's why it's written like that. And then we're going to graph linear equations given an equation. So slope-intercept form. So m is the rate of change. But for graphic purposes, it's actually your slope. All right, b is your start value. But for graphing purposes, it's your y-intercept. It's where it's crossing the y-axis, okay, where the line is crossing the y-axis. So write the equation of a line given the slope and y-intercept. And this is super simple, okay? When they're giving you these two things, you're just saying m equals -2, b equals 5. So you're just going to write it in y. In y equals mx plus b. You're just going to replace these in there. So it's going to be y equals -2x plus 5, and that's your answer, and that's it. Over here, your slope is 3/4, and your y-intercept is -3. So you're just going to have y equals 3/4x minus 3. And I just want to make sure I pointed out, the rate of change, the slope is always next to the x. The y-intercept does not have a variable next to it. So that's a really good way of understanding, actually identifying which one's which. Write the equation of a line in slope-intercept form given a graph. So again, the main two objectives in slope-intercept form are, what is the slope, what is the y-intercept? So the slope, they're giving you 2 points over here. So from left to right, draw a little triangle. Whoops. So draw a triangle going left to right. I don't mean right to, like, go up and down first and then go right and left because of the rise over run thing. Don't draw this triangle. It actually messes it up. So up and down from right to left, you are going up 1, 2, 3, 4 spots. There's going to be 4 over. And you're going to do 1, 2, 3 spots. It's 4/3. And just check to see if your sign matches the graph. This is going in the positive direction, so this is a positive slope. And what is your y-intercept? It's where it's crossing the y-axis. And in this, it's crossing the y-axis at 0, -5. And the value for b comes from the y value. So it's going to be -5. And now in y equals mx plus b, you are just replacing these two numbers. So it's going to be y equals 4/3 x minus 5. Let's do this one together. So again, go up and down first. So you're going this way. So this is what your triangle would look like. And now up and down is going down 2 spots, 1, 2, down 2 spots. So it's going to be -2. And it's going to the right 1, 2, 3, 4. Right 4. And when you simplify this, you're going to get -1/2. As I said, one thing I do want to point out is that I like to keep the change of x, the left and right one, positive. And I like to keep the change in y positive or negative, depending on if it's a positive graph or negative graph. I think it really helps kids when you're consistent with something like that. But as long as you know that you're going up and down, remember it's a rise over run thing. That's all that matters. And your y-intercept, again, is where is it crossing the y-axis? And it's crossing the y-axis right here, and that point is 0, 1, so it's going to be 1. So in y equals mx plus b, you're going to have y equals -1/2 x plus 1. And you could put that negative in the middle, like right before the fraction. You could put the negative with the 1. You could put the negative with the 2. They're all fine as long as you only have one negative. You can't have negative, negative, because negative divided by a negative is a positive. Oh, I have the equations right here, but you can write them down there. All good. Write a linear equation of the graph shown. So what I'm going to do is point these out over here. They have points over here, and I'm just going to pick your 2 points. One here and one here. And I'm going to pause the video, and I want you to try it on your own and see if your answer matches mine. Okay, welcome back. These are your 2 equations, y equals 4/3 x plus 2. From the slope and the y-intercepts. And now the slope of this is -3/2 because it's going down first and then positive right. Remember, it's a negative graph anyway, so just make sure you get that. And the y-intercept this time is a -3. You're more than welcome to write plus -3, but you're never going to see that written in a textbook like that. So not a bad idea to just keep it like this. Okay. Write an equation of a line in slope-intercept form given a table. All right, so remember, as always, the 2 things that you want to find is the slope and the y-intercept. So they're telling you slope there, and you have to also find the y-intercept. The y-intercept is always the easiest one. As I've said, just find the value where x equals 0. So x equals 0 here. So the y value is 1, so your y-intercept is 1. Your start value is 1. And now finding the rate of change. So this is change in y over the change in x. So you're just going to keep looking at it go from top to bottom, all right? Don't go, when you're having a table, it has to be chronologically from x is going from the smallest value to the highest value, or none of this makes any sense. So you are adding 2, adding 2, adding 2, adding 2, adding 2. So that's your change in y. And the change in x is +1, +1, +1, +1. So it's going to be 2/1 or 2 you can write, and that's fine. And now you have your 2 values. You're going to have y equals 2x plus 1, and that's your equation. How many more do I have here? Whoops. All right. I just kind of did it all in one shot. This is saying first find the slope, but I kind of did it all in one shot. So I'm going to do 2 more examples with you guys, and you can do the ones down there. All right. So slope, y-intercept. All right. Might as well just find everything and do it at the same time. So remember, y-intercept is where x equals 0. So this is 3. That's the easy one. And now you're just going to do what is happening here. So you're doing 4 to 3.5 is minus 0.5 minus 0.5 and you want to keep checking. This is something you don't want to assume, because you're going to have things that are going to be asking you at some there might be problems. Is this a linear equation? Well, it's not going to be a linear equation if the rate of change isn't consistently like the same rate. And this is going to be +1, +1. It just all happens to be +1, +1, +1 thing down here. So it's -0.5/1 every single time. So this is going to be negative, or you can just write -0.5. And okay, so the actual equation is y equals -0.5x plus 3. I don't care if you write it like this, but if you are graphing it, if you need to graph it, I would sometimes might just be easier to create that decimal into a fraction, whereas -1/2x plus 3. Again, it's got to gauge your teacher in this one. I really wouldn't care as long as you understand how to do it, vice versa. Let's do one more problem. So your y-intercepts. I always think it's the easiest one to find first. That's why I do it first. X is 0 here, so this is -1. Now let's look at this. -16 to 7, you're adding 9. -7 to -1, you'll realize that things are changing a little bit here. So this is going to be adding 6. -1 to 8 is +9. And if you're not sure with your positive and negatives, then maybe this is a problem that you skip for now. You're just trying to understand concepts. And this is going to be +6. And you notice that it's changing, but you're going to see why this matters. And now in the x's, it's +3, +2, +3, +2. And why this is the same rate of change as 9/3 is 3/1. 6/2 is 3/1. 9/3 again, 6/2 again. So you know now that your slope is just 3/1 or 3. So this is why you need to keep checking the change in y's and the change in x, because it does matter. It needs to be consistent. There's going to be time where it's not a linear function. It's going to be something else that is not linear. So you have to check. And now your equation is going to be y equals 3x minus 1, and that's it. What I want you to do again is pause this video and do these 3 problems on your own. All right, bye. Or not bye, just pause. I'll be back. And I just realized these are the same problems up there, so don't worry about doing it. I'm sure you recognize it too. I'm just going to scoot down below, okay? So what should you do if 0 is on in the table? Find the slope. So you're going to have +4, +4, +4, +4, +1, +1, +1, +1. So we know that now it's increasing by 4. So if you go backwards, you're going to have 0 here, +1. And if you're adding here, you have to subtract. So 11 minus 4 would be 7. So you have now the slope is 4. So it's going to be 4x. I mean, there's several ways you can do it. You can plug it back in. That's another method, but this works too if you can handle it. I'm going to go over that method in the future. So this is going to be 4, and the y-intercept is 7, and you're going to have your equation y equals 4x plus 7. But I promise you I'm going to show you this, how to solve it in a future lesson. I just think it's too much for now. Yeah. I'm going to skip that. All right, I'm going to skip all of this. I just want to get to graphing. All right, graphing, and I don't have that much time, so I'm going to try to do this really quickly. So big thing with graphing is slope is rise over run. You're running, and you're rising and you're running. But the first thing is you have to identify your slope, which is 2, but you have to write it as a fraction. Okay, I'll talk about that in a second. And your y-intercept is 1. So you always want to, the reason the y-intercept is called a start value is this is what you want to actually plot first. So it's crossing the y-axis at 1. You have to plot that first. And now you're doing your slope, which is 2/1. It's called rise over run because you're rising 2, and then you're running 1. This is what you're going to keep doing. You're rising 2, and you're running 1. Rising 2, and you're running 1. You're going to keep going on with that. So from that point, you're rising 2, running 1, rising 2, running 1. And now you just have your connected dots, and you have your line. So this one over here, your slope is -2/3. And I like to make one of them negative, and it's usually the numerator. And your y-intercept is -2. So -2. So now you're going down 2 into the right 3. Down 2 into the right 3. And that's your graph right there. Running out of time, so don't worry about this one. If you don't get this, the idea is here, but what you want to do is just, okay, I'm just going to stop here because I'm running out of time. Bye.